Yeah, I'm Mark. I work for GearSet up in Belfast. In fact, I got the keys to my new house at 3 o'clock yesterday, so this is the quiet, relaxed part of my day. I'm going to be heading back to move boxes and all sorts of stuff after this. But I'll be mostly dealing with my experience before that. I've only been with GearSet a few months, and before that I was a freelancer for 20 years. So, I was dealing with consultancy and things, and as part of that journey, I like to do things serverlessly and event-driven and stuff, but not everybody is ready for that. Not everybody wants to. So this is about how you might be able to sneak that sort of thing into your serverless, into something that they don't want serverless. Basically, we'll start with what I mean by serverless, because this is serverless days. I'm assured it's not Lambda days or Azure Functions days or FAS days. It's serverless days. So there's been a little cynicism about what I'm going to tell you now, whether it counts as serverless, but we'll see where we go. So all the software you're writing starts with some work you need to do. So it's a CLI and somebody's typing something in, giving you the work, or it's just a cron job and the work is just the fact that the time comes around again. Or you might have messages coming in on a message queue somewhere, or you've got events coming in from some external system that fly in and you need to process those. But basically everything you're doing, there's some work that you need to do, and you're devs, so you're going to build some amount of code that deals with that work. So that could be a function, it could be an executable, it could be a huge great monolith, depending on where you are. But you've got work, you've got code, and then the code runs and it produces an answer, or it produces side effects. So you're writing to a database or producing more messages for things to deal with. So pretty much everything that you write is going to be that pattern: work, process, output. Generally speaking, you'll have several of these. So, you'll have work, process, output, and the output will then feed into other functions or other executables or other, Lambda functions or, sort of somebody else's monolith. And, you compose your application just out of these, whatever size of things it is that your maturity gives you. And to me, all that serverless is that, you take that and you said, yes, who's got two thumbs and found the animations thing in PowerPoint? Yes. What you're going to do is, serverless is going to be looking at the size of your workload and scaling up your compute accordingly. And, at the end of the day, that's all serverless is. It's nice to have it, sort of have all the event-driven stuff going on and stuff, but at the end of the day, all serverless is scaling. So if you've got no work to do, you're not doing any work and you're not paying for it. If you've got lots of work to do, you get lots of compute and you pay a bit more. Now, that's great, and if you want to do that with functions as a service, that's the best way to do it probably, but not everybody wants to do it like that. There's a couple of problems, particularly from the business point of view. You find, if you're using a function as a service, you're immediately tied to a specific cloud provider. So you're tied to AWS or Azure or Google or what have you. And particularly when you get to the larger companies, they're not always comfortable with that. They don't like lock-in. They don't like being tied to something. Somebody, there's always this feeling they've got that, they're suddenly going to get the price doubled, and sort of everything's going to go wrong. Are they right? I don't know. I don't run big businesses, but they think it's a legitimate concern. They're also not necessarily particularly happy about the fact that they can't predict their costs. So they're used to every month they get a fixed bill, and they're happy with that. If you give them something that can get cheaper, they're not so bothered about whether the fact it can get cheaper, they're bothered about the fact it can get more expensive. Particularly, there's always this feeling sort of that floats around them that, if somebody comes along, a bad actor, and starts firing lots of requests at their server or whatever, that all of a sudden they're going to get this denial of wallet attack and the huge bill's going to come in. And the final one, which is certainly something I come across quite a lot, is just that, they've got an ops team who like Kubernetes, and everybody's very happy with Kubernetes. That's just a bit of clip art there, obviously, but it does very much show the growth of Kubernetes. So, I think this last time the CNCF looked into this sort of thing, it was something like 70% of companies are now using Kubernetes in production, and 95% of them have got Kubernetes running somewhere in, sort of in test or in one of the background processes that they're running. So, there's a lot of companies, like GearSet, where everything runs on Kubernetes, and they're just not interested in bringing in other services. They want to keep everything in Kubernetes. On the other side of things, you've got the functions as a service going on for developers. Now, again, you might not think of these as big problems, but they can be. Only some stacks supported. Now, true story. My daughter's PhD, she was doing some theoretical physics work, doing simulations. She got to the stage where she needed to scale up the processing that she was doing to do lots of simultaneous analyses of things, to do whatever weird thing it was she was doing to do with light and emissions and diffusion and stuff. The problem was that the code that she was using had been built over many, many years by theoretical physicists. And theoretical physicists, because of the nature of the computation, like to write things in Fortran. And you can't run Fortran on the average functions as a service system. So, yes, it's a true story. Further on down the line here, we'll see what we're doing. But yes, I have written serverless Fortran. Even if you're on one of the supported stacks, then there's particular patterns you have to deal with. So you've got your step functions or your durable functions. You have to code it to the particular SDK of the cloud provider that you're using, and along with that, your function it can't do that much. You can't even host a blooming web. You've got this wonderful compute platform. You can't even host a website on it. What's that all about? So that's the problem with it. And also, when you're doing local dev work with functions as a service, you've always got this problem that you're not that close to what's really running out in the cloud. So even if you're on one of the platforms that has an open source runtime, you've still got that problem of debugging and synchronizing all the stuff locally. It's not, it's a little bit of a pain in the backside to get it working. So we go back to this. From the developer point of view, that's all software. Now, of course, these days, all software runs in containers. So, even if you're not building containers yourself, if you're running functions as a service, your function as a service is going to be running in a container on your cloud platform. That's just the way life is these days. Everything runs in containers. And, as a developer, I like things that run in containers because it's a lot easier to deploy stuff when it matches exactly on my machine what matches out in the cloud or wherever I'm running it. So, again, here, what we've got, we've got this bit in the middle here between the work you're doing and, sort of the thing that's processing it, so this container. So your serverless thing is looking at the amount of work you do, like I say, and scaling up and down accordingly. So the number of containers that are running will be based on the size of the work. So really, the serverless bit there is looking back to the workload, see how much work is in that queue, and then producing the right number of containers to process that in a timely manner, and then going the other way, you also need a bit of something that takes that work and feeds it through to your container in some way, shape, or form. So that's all you really need to get a serverless container-based system going, is those two things. Moving on from that, most of the cloud providers have some sort of managed semi-serverless platform. So AWS has App Runner, GCP has Cloud Run, and Azure has Azure Container Apps. Now, what these usually do is, they're essentially a simple container orchestrator. And what usually happens is that, you can say, okay, these containers, I want that, if they're going to be triggered by some sort of HTTP traffic, and the more HTTP traffic that comes in, the more I want to scale that up. So they're watching that. Now, the downside of scaling on HTTP is that it's kind of a reactive thing rather than a proactive thing. So if you've ever run a website that suddenly gets busy, when all you know is you're getting a whacking load of sort of HTTP requests all suddenly come in because it's the time of day that the Ed Sheeran tickets have gone on sale or whatever, but you don't know how large that is. So you can scale it, but it's still a little bit on the brittle side. Azure Container Apps, which I'm only going to do one slide on because this is not to vendor pitch, but Azure Container Apps has a more interesting way of looking at this. So again, it's a container orchestration platform. Now, it's quite opinionated, so it's got everything built in for you. So it's got security, it's got all the networking between the containers and stuff. All the observability stuff is just there out of the box. So you don't have to configure it. It's just there, same as if you're running a functions as a service platform. That's all there, ties into sort of Azure Monitor and sort of things. And it's got an extremely simple configuration. So what you're basically just doing, you're giving it some YAML because it's the cloud and you have to do YAML in the cloud. But essentially, you just say, okay, this is my container, so this is where my container image lives. This is where its workload is, so it's either a queue, an SQS queue, or it's an Azure Service Bus queue, or it's this database table, or it's HTTP, or whatever it is. You tell it what the workload is, and give it the parameters of how much you want your container to scale, so a minimum, maximum, and hey presto, it will scale that up. And the other thing it has for each container is you can say, for this workload, this is where I want to get my workload in, and just send it via HTTP or gRPC to my container. So as long as your container can host an HTTP endpoint, which even Fortran can, then you can configure Azure Container Apps to watch your workload, scale up and down, and read all the work that's coming off that, and do the work. It's got APIs for various stacks as well, so if you're using .NET or Java or Go or whatever, you can easily hook into that to, so you don't have to do all the reading of stuff yourself. And being because Azure decided to make this a serverless-friendly, serverless-first type of orchestration platform, it also has the pricing for that. So it will scale like functions as a service, and you just pay for what you're using. The other nice thing it has is that, if you just got a non-scaling container in there, so just a website or something like that, it actually has a 10% charge for times when you're not using it. So even though you can have a website sitting there ready to go all the time, you're only getting charged for the amount of time that it's actually busy, pretty much, which is just a nice little extra. It's not strictly relevant to what we're talking about here in terms of how you sneak in the serverless, but that's how it works on the container apps. So that's a really nice platform. I actually use that a fair bit rather than the plain functions as a service, just because I like container-based development, and I like the fact that it's a lot easier to do the development workflow for that, and then just push it up to the cloud, and hey presto, it's running serverlessly. Now, the nice bit about Azure Container Apps is that it actually is Kubernetes. So your great big company there that runs everything on Kubernetes, if you've got a Kubernetes cluster, there are these two open source extensions for Kubernetes called Kida and Dapper, and they do the scaling and the connection bit. It's also got Envoy built in there, which is the standard Kubernetes networking thing, and obviously they've taken out all the complexity of running Kubernetes, but at the end of the day, it is Kubernetes. So if you've got something that can run on Azure Container Apps, you can actually run it. You can sort of come out of Azure Container Apps and dump it on Kubernetes and do exactly the same thing. The way that works is, the first one of those two extensions is called Kida, which is the Kubernetes event-driven autoscaler. So the way Kubernetes tends to work is that, it's got a number of virtual machines and it spreads the work of your containers across those virtual machines. And it's got this thing called the horizontal pod autoscaler, which basically, normally just watches CPU and memory utilization to decide how many containers you've got. But you can hook into that and extend it. So what Kida does is you can tell it what your workload is. So like I say, HTTP or a timer or a queue or a database table, or whatever it is that you're getting your work in from, and it's got about 50 different ones. And it will use that workload to scale your containers so that Kubernetes can then sort of spread those across the VMs that it's running. You'll notice, as well as all the sort of cloud ones there, you've also got things like RabbitMQ and stuff. So you can actually have that hosted within your Kubernetes cluster, so you don't need to have cloud services outside it. The other thing that works well with this is what's called virtual nodes. So all the cloud providers have some sort of non-VM based way of running containers, so Fargate or container instances or whatever. So if you set up what's called a virtual node, then it will sort of essentially pretend that your cloud is a virtual machine and use that to scale the pods out. So you essentially get an infinitely scalable virtual machine to run your nodes and your pods. So that's the first part of the magic of serverless is just the scaling up and down. So that gives you scale to zero to scale to wherever of whatever it is you're running. And the other thing that's built in there is this thing called DAPR, the Distributed Application Runtime. And that's the thing that allows you to easily connect your code to the workload. So it does a number of things, but the main one from our point of view here is what, the resource bindings and triggers there. So what it will do is, if you've got a message coming into your message bus, it will watch that message bus, it will package that up as a cloud events message and fire it to your HTTP endpoint. So all you have to do is say, take this workload, send it to my HTTP endpoint, there's the work, you can do something with it. It will also do outputs as well, so if the thing you want to do at the end is to write to a database or write to another queue, you can easily bind that in. And when you're using DAPR, because all your traffic goes through DAPR, between you and the workload and between you and other pods, other containers, you get all the observability and stuff built in and all the networking built in. So as we were talking about earlier, you get all that stuff without having to do anything specific necessarily for Kubernetes. It does actually run on anything. It's literally just a little sidecar or process that runs next to your own code and talks to it over a gRPC connection or an HTTP connection. So, you can run this on a Raspberry Pi if you really want to. You can run it on your on-premises Kubernetes. You can run it on your cloud Kubernetes. You can run it on your own PC. It all just works very nicely. But basically, so going from functions as a service, through sort of the managed cloud provider, sort of container platforms, through to Kubernetes, you can see that this is actually how a lot of this works under the hood anyway, on your functions as a service in the cloud. But yes, you can take a company that refuses to run anything that's not multi-cloud, refuses to run anything that scales infinitely, or refuses to not do anything that isn't Kubernetes, and you can actually run a fully serverless system on Kubernetes. The developer experience is on a par with functions as a service, slightly different, pros and cons, but like I say, I would use Azure Functions sometimes and container apps sometimes, and I can dump that onto Kubernetes if I want to. Because it's on Kubernetes, there is no company out there in the world that won't let you run something that's container-based in Kubernetes. And Azure Container Apps, if you want to get started, you can use Azure Container Apps to do a nice, cheap prototype, or actually just run it in that cheaper until the time comes when you really need the full Kubernetes. So, just a couple of links there if you want to look up Kida and DAPR and how Container Apps works there. And, that's me.